This is lesson 1.3, fractions. Our learning objectives are to simplify fractions, multiply and divide them, add and subtract them, use the order of operations to simplify them, and evaluate variable expressions with fractions in them. Let's begin by talking about simplifying fractions. First of all, what is a fraction? Well, a fraction is just one thing divided by another thing. So in this definition here, it says a fraction is written a divided by b, where b cannot equal 0. A is called the numerator and b is called the denominator. So if I had a fraction like 4 over 6, 4 is the numerator and 6 is the denominator. Now, we have equivalent fractions. Equivalent fractions are fractions that have the same value. So 4/6 is actually an equivalent fraction with 2/3. They are equal to each other. They have the same value. Now, the equivalent fractions property says if a, b, and c are numbers where b cannot equal 0 and c cannot equal 0, then a times c divided by b times c equals a over b. Well, let's look at 4/6. 4 can be written as 2 times 2, and 6 can be written as 3 times 2. So according to the equivalent fractions property, we can cancel the common factor of 2 out of the top and bottom. And that's why we can say 4/6 is equal to 2/3. Well, let's look at some examples with some slightly larger numbers. In example 1.24, I see the fraction 12/18. And I can break 12 into pieces because I know 12 is 2 times 6. And I can break 18 into pieces, like I know 18 is 3 times 6. I notice that 6 is a common factor in the numerator and denominator, so it can be canceled. And I'm left with 2/3. So 12/18 is an equivalent fraction of 2/3. But 2/3 is the reduced fraction. It's been simplified. We always want to simplify fractions if possible. Let's look at another fraction, negative 20 over 25. Fractions can be negative, so we see this negative in front of the fraction. And 20, well, it could be broken down into 4 times 5, and 25 is 5 times 5. Well, I see the common factor of 5 in top and bottom, so I cancel it. And my equivalent fraction is negative 4/5. Whenever I complete an example in our lesson, there is a try it on the right-hand side. You can pause the video and you can try any example throughout the lesson. Let's move forward and talk about multiplying and dividing fractions. So we could take two fractions and we can multiply them, or we could divide them, or we could add or subtract them. So think of the basic 4 operations from 3rd grade onwards. So we're going to use those operations with fractions. Let's begin with multiplication. So if I have two fractions like a over b times c over d, then I can multiply their numerators together to get a result in the new numerator, and multiply their denominators together to get a new denominator. And that's how simple fraction multiplication is. Whenever you have done that, you want to simplify the resulting fraction if possible. Let's look at example 1.25. So I see 2/7 times 3/4. So let's multiply the numerators together. 2 times 3 is 6. Let's multiply the denominators together. 7 times 4 is 28. Now, 6 and 28, they share a common factor of 2. So I'm going to think of just dividing a 2 out of the top and bottom to reduce the fraction. So 6 divided by 2 is 3, and 28 divided by 2 is 14. This is reduced fully simplified. Let's try another. 2/3 times 5/6. 2 times 5 is 10, and 3 times 6 is 18. I notice that they share a common factor of 2 again. So I divide a 2 out of the top and bottom, and I get 5/9. 5/9 is the reduced fraction. Now that we have worked on multiplying fractions together, let's talk about how to divide fractions. So before we do that, we need to talk about reciprocals. The reciprocal of a fraction is found by inverting the fraction, placing the numerator in the denominator and the denominator in the numerator. So we flipped it. Really quick, if I had a fraction like 2/3, what is the reciprocal of 2/3? Well, it's 3/2, because the denominator went to the numerator and the numerator went to the denominator. So the reciprocal of 2/3 is 3/2. Now, we need to use a reciprocal when we talk about division of fractions. So when I divide two fractions, like a over b divided by c over d, we multiply the first fraction, keep it the same, but we turn division into multiplication, and then we flip the second fraction. So c over d becomes d over c. It'll make sense as we try an example. So if I see 3/4 divided by 2/3, I would quickly rewrite it as 3/4 times 3/2. So what I did was keep the first fraction the same, switch division to multiplication, and flip or take the reciprocal of the second fraction. So I did a keep, switch, flip. Okay, now fraction division has become fraction multiplication. And so I multiply like I learned before. 3 times 3 is 9, and 4 times 2 is 8. I get 9/8, and I notice that I can't find a common factor of the numerator and denominator, so it's fully simplified already. Let's try that again. So I see a division of two fractions, and I quickly decide to rewrite it as 3/4 times 5/4. So I did once again, keep the first fraction the same, switch division to multiplication, and flip, take the reciprocal of the second fraction. So I multiply the numerators together. 3 times 5 is 15. I multiply the denominators together. 4 times 4 is 16. My result is 15/16. Sometimes we see division problems as a complex fraction. A complex fraction is a fraction in which the numerator and or the denominator have fractions. So they're fractions inside of fractions. Don't get scared. It's just a fraction divided by a fraction, just like we were just doing. So you could think of going through the same process we did above with keep it. Switch the middle division symbol to multiplication, and then take the reciprocal of the bottom fraction. So here I have x divided by 2 is the top fraction. I switch division to multiplication, and then I take the reciprocal of the bottom fraction. So that becomes 6 over xy. Now I see it, I could multiply these fractions together. So x times 6 gives me 6x. And then 2 times xy gives me a 2xy. Just think of variables as factors. So I see a common factor of x on top and bottom. They cancel. My final answer is 6 over 2y. Great. So you will do the same method of fraction division, whether you see it like this or like this. It's the same. Let's move forward and talk about adding and subtracting fractions. Now, we have first a definition that we need to talk about, and that definition is of a least common denominator. The least common denominator of two fractions is the least common multiple of their denominators. So in our last lesson, we talked about least common multiples, and we can use this to help us with adding and subtracting unlike fractions. So here are operations of addition and subtraction, but we have two different cases. So we have the addition and subtraction of fractions with like denominators. That's where you have the same denominator in both fractions, like we see here. If that's the case, it's really simple. We simply add the numerators and keep the common denominator. So take a and b and add them together in the numerator, and then just whatever your denominator was, keep it the same in your final answer. That's the same thing for subtraction. So if I have a over c minus b over c, so a common denominator, then I can subtract the numerators and keep the denominator the same. Now things get a little bit more difficult when we want to add or subtract fractions that don't have the same denominator. Here's an example, like if I had a over b plus c over d, well, I could take a and multiply it with d, and add b multiplied with c, and divide that by b times d to add the fractions together into one fraction. So that always works. What's really happening here is we're finding a common denominator, rewriting both fractions, and adding the numerators together. Same thing for subtraction. The only thing that's different is that instead of a plus sign, we now have a minus sign. So if I see a over b minus c over d, then I take a times d minus b times c, and I divide it by b times d. All right? So that will always work. Now, once you've done that, you want to be sure to simplify the resulting fraction if possible. Well, let's go ahead and try adding fractions together. So if I see 3/5 plus 4/5, well, I get excited because I see a common denominator of 5. All right, so that makes life really easy because all I have to do is add their numerators, 3 plus 4, and I get 7. Okay, so my answer is 7/5. These were like denominators. But let's make things slightly different. What if we had 3/5 plus 4/3? Now we don't have a common denominator. So we could do our trick we learned up top. So we could take 3 times 3 plus 5 times 4 and then divide it by 5 times 3. All right. Now, 3 times 3 is 9. 5 times 4 is 20. 5 times 3 is 15. So I'd get 9 plus 20, which is 29, over 15, and that would be my answer. Let's try fraction subtraction. In example 1.28b, I'm going to take 3/5 minus 4/5. And I notice, well, they've got the same denominator, so life is easy. And I take the numerators, 3 minus 4, which is -1. My answer is -1/5. Now, let's take 3/5 minus 4/3. We notice the denominators are different. So we'll multiply 3 times 3 and subtract 5 times 4 and divide by 5 times 3. Once again, 3 times 3 is 9, 5 times 4 is 20, 5 times 3 is 15. So our result is 9 minus 20, which is -11, divided by 15. That fraction cannot be reduced. It doesn't have a common factor on top and bottom. Moving forward, let's put it all together. So we're going to do an example that has fraction multiplication, division, addition, and subtraction with the same two fractions. I'm going to zoom in. So 3/8 times 1/6. Well, when I multiply, I just multiply the numerator together, 3 times 1, and the denominators together, 8 times 6. I ask, can I reduce any further? Well, 3 and 48 are both divisible by 3. So you could think, oh yeah, I'm dividing 3 out of top and bottom. So I get 1 over 16. Next, let's divide. 3/8 divided by 1/6. You'll remember when we divide, we turn it into multiplication with keep, switch, flip. So let's keep 3/8, switch division to multiplication, and take the reciprocal of 1/6. 3 times 6 is 18. 8 times 1 is 8. Now, 18 and 8, they share a 2 in common. They have a common factor of 2. So if I divide a 2 out, I will reduce the fraction. I'm left with 9/4, and that can't be reduced any further. All right, let's practice some addition of fractions. So when I see two different denominators, unlike denominators, then I'm going to take 3 times 6 and then add it with 8 times 1 and divide 8 times 6. Well, 3 times 6 is 18, 8 times 1 is 8, 8 times 6 is 48. All right, so 18 plus 8 is 26, and that's divided by 48. I notice, well, both are reducible by a factor of 2, at least. I think just 2. So I'm going to divide 2 out of both of these, and my final result is 13 over 24. Lastly, let's try subtracting these two fractions. Well, they don't have the same denominator once again, so we're going to multiply 3 times 6 and then subtract 8 times 1 and divide by 8 times 6. And once again, we get the numbers 18 and 8 and 48. And 18 minus 8 is 10 over 48. We notice they share a common factor on top and bottom of 2, so I'm going to divide a 2 out of both of them. And I get 5 over 24. 5/24. Great. At this point, my hope is that I've helped you to become comfortable with multiplying, dividing, adding, and subtracting fractions, whether you have like denominators or unlike denominators. Moving forward, our next objective is to use the order of operations to simplify fractions. You'll recall that the order of operations is an acronym PEMDAS for parentheses, exponents, multiplication, division, addition, and subtraction. So when we encounter fractions, it's important to note that the fraction bar is in a fraction acts as a grouping symbol. The order of operations then tells us to simplify the numerator and the denominator, and then we divide. So something important here is a negative sign placement in a fraction. So for any positive numbers a and b, negative a over b is equal to a over negative b, which equals negative a over b. In the end, it doesn't matter whether you have your negative symbol on the top of a fraction, on the bottom of a fraction, or before the fraction. They are equivalent fractions. Most commonly, we like to report our answer with a negative in front of the fraction. All right, so let's dive into simplifying some of these fractions with PEMDAS. When I see this fraction in example 1.30, I can do the operations that I see in order that I see them. So like 4 times negative 3, I can multiply that to make negative 12. I see the operation of addition. 6 times negative 2, that gives me negative 12 as well. And then on the bottom, I have negative 3 times 2, which is negative 6, and then minus 2. Let's take it further. Negative 12 plus negative 12 is negative 24. And negative 6 minus 2 is negative 8. One important thing to note is when you take a negative times a negative, it's a positive. Same thing with dividing. A negative divided by a negative is a positive. So these negatives will cancel each other. And 24 divided by 8 is 3. Great, so we just took this big fraction with lots of operations and we simplified it. It is now just 3. That's great. Example 1.31. Let's simplify this fraction. It has 1/2 squared divided by 4 plus 3 squared. Now, when you raise a fraction to an exponent, you apply the exponent to the numerator and the denominator. So 1 squared is 1 and 2 squared is 4. And that's divided by, well, 4 plus 3 squared, 4 plus 9. Let's simplify the bottom further. So I have 1/4, and that's divided by 13. Now, anytime you have an integer, like in this case 13, you could turn an integer into a fraction by dividing by 1. So any integer is really a fraction with an invisible denominator of 1. You could always make that denominator appear. Why would I do that? Because I'm about to keep, switch, flip. This is fraction division, right? So I keep the numerator's fraction the same, switch division to multiplication, and take the reciprocal of the bottom fraction. So it becomes 1/13. And now I have fraction multiplication. 1 times 1 is 1, and 4 times 13 is 52. So we have simplified this starting fraction into 1 over 52. Moving forward, we now have example 1.32. It says simplify. And we see fraction addition on top, fraction subtraction on bottom, and then eventually we're going to have to probably do fraction division to finish simplifying. So this is a nice little process. We're going to do a lot of operations on fractions. Let's start with the top. 1/2 plus 2/3. Well, we have fraction addition with different or unlike denominators. So let's work on that first. 1 times 3 plus 2 times 2 divided by 2 times 3. Now we have the big division symbol in the middle of everything. And now let's do fraction subtraction with unlike denominators. So that would be a 3 times 6 minus 4 times 1 divided by 4 times 6. Great. So cleaning this up a little bit, 1 times 3 is 3, 2 times 2 is 4, 2 times 3 is 6. And 3 times 6 is 18, 4 times 1 is 4, 4 times 6 is 24. So I have 3 plus 4 over 6 divided by 18 minus 4 over 24. Let's do 3 plus 4 gives us 7. Next, 18 minus 4 gives me 14. Now it's time to keep, switch, and flip. So 7/6 times 24 over 14. Now, before I multiply everything together, it could be nice at this point to reduce, find common factors on top and bottom. Let me show you an example. 7 over 14, right? 7/14. Well, 7 and 14 are both divisible by 7, so we could write them as 1 over 2. And, well, 24 over 6 are both reducible by 6. So 24 divided by 6 is 4, 6 divided by 6 is 1. Because I've done this, it's now much easier to multiply things together. So 1 times 4 is 4, 1 times 2 is 2, and 4 divided by 2 is 2. Here's my final result. So looking back, we saw something that appeared really complicated, like all this stuff. And we did what we know about fractions to simplify addition and subtraction and division, and we ended up with a really simple answer. All of that was really just 2 in disguise. Our final example of this lesson is to evaluate variable expressions with fractions. You'll recall from our very first lesson this semester that to evaluate means to plug in. All right, so we're plugging in values that are given for the variable. In example 1.33, we're told to evaluate 2 times x squared times y. And so we're given that x equals 1/4 and y equals -2/3. Let's take this and plug in the given values in their appropriate places. So I have 2 times x, which is 1/4, squared times y, which is -2/3. Now, you'll recall that when you square a fraction, like we are in this case, we square the numerator and we square the denominator. So I can rewrite this all as 2 times 1/16, right? Because 1 squared is 1, 4 squared is 16, and that's multiplied then by -2/3. We could multiply the fractions together first. So 2 is multiplied by 1 times -2/3. Sorry, 1 times 2, right? And 16 times 3, which is 48. Now, the number 2 in front of this fraction, it's an integer being multiplied by the fraction. You could always turn an integer into a fraction itself. Right? 2 is the same thing as 2 divided by 1. You can make this division by 1 appear so that you can treat this as fraction multiplication. So let's multiply these two fractions together now. 2 times -2 is -4, and 1 times 48, well, that's 48. Now, is this reducible? Yes. It's reducible by a factor of 4 because 48 is a multiple of 4. So my final result, I'm going to put the negative in front of the fraction, and 4 divided by 4 is 1, and 48 divided by 4 is 12. There we go. -1/12 is the answer. We've completed lesson 1.3. This is a great time for you to go to your 1.3 assignment in WebWork and to practice what you've learned about fraction, multiplication, division, addition, and subtraction, how to handle operations in the correct order with PEMDAS, and how to evaluate variable expressions with fractions. Have a good day. Thank you.